All right, pre-calculus. This is our third installment in our series for inverse functions. So in this one, I'm going to look at specifically how do we go about proving that two functions are inverses of one another. So I'm going to start off here with a couple of functions. I'm going to have an example where we are going to see that they are inverses, and then another example where they are not going to be inverses. And how much work do we really need to show in order to be able to prove it mathematically. So I'm going to be looking at how to do this algebraically first, and then we'll verify our answers by looking at a graph. All right, so I'm going to start by writing my first functions or pair of functions here. So I have f of x is equal to, and I'm going to say 2x plus 3, and then I'm going to have g of x be x over 2 minus 3. So are those inverses of one another? So how do I prove this algebraically? So the definition of whether or not two functions are inverses of one another algebraically is to say if f of g of x is equal to x and g of f of x is also equal to x, then f and g are inverses. That's what we have to show. And the reason this works is because we're saying if you put one inside of the other, doesn't matter which way we do it, if they're truly opposites of one another, they will undo each other, leaving you with whatever you started with. And that's essentially the nature of an inverse, right? If I put addition and subtraction together, it doesn't matter whether you add first and then subtract, or you subtract and then you add, they're going to cancel each other out and it becomes nothing. Same thing with multiplication, division, radicals and powers. There doesn't matter the order in which we do the operation, you'll get the original thing that you started with when you do it. All right, so first, let's look at doing f of g of x. So this is where I said that earlier section on compositions of functions is going to become of big importance here. So I'm starting first with substituting my g of x. So I see g of x above was x over 2 minus 3. Okay, so now I substituted, now I'm going to substitute again. So f, wherever there was x, now turns into this expression. So it's going to say 2 x over 2 minus 3 plus 3. Okay, so now, I'm going to simplify this out. So again, this is the setup. Now we're going to do the cleanup because I want to see, do I end up with x when I finish this? So I'm going to distribute the 2. So this becomes x minus 6 plus 3. And then we end up with x minus 3. So this is our final expression for f of g of x. Is this x? No, it's not. We ended up with x minus 3. So right here, I would stop doing my work and I would conclude, therefore, f and g are not inverses. So this, all I have to do is as soon as one part, because there's two parts to this definition, as soon as one of these two parts doesn't work, that's it, we stop. I'm not going to now do g of f of x. I'm not going to do that extra work if ultimately it's not going to change the conclusion. So that's it. These two things are not inverse functions of one another. If this ended up saying x, then I would have to move on to the next condition, which is to see, if I do it the other way, do I still end up with x or does it now change? So that can happen. All right. So just to kind of show you here, not having to do extra work if it's really not necessary. Okay, so I'm going to go back now and I'm going to write two functions that I know are inverses of one another. Okay, so I'm going to reset these, and I'm going to start with, so I'm going to say x squared plus 3, where x is less than 0. And then I'm going to have x minus 3 square root. All right, so those are my two functions that I'm going to plot. Oh, sorry, let me put a negative here. Forgot about that. Because I'm setting it up so that I know they're going to be inverses, okay? But let's say now I was given this in a problem set. How do I know if they're inverses? This has this weird thing attached to it at the end. I see a negative here. Uh-oh, this doesn't seem to me like it's an inverse. So how do I know? We do the composition, okay? So let's go ahead and we'll start with that first. So we start with g of x. So we'll substitute that into f. So this is going to say negative square root x minus 3. And now we'll plug that into x above. So here we have x squared plus 3. So anything that was x, it's now replaced by all this. So it's going to say negative x minus 3 squared plus 3. Okay, so there's my setup. Always important that we show our steps so that if we mess up on the algebra later, at least this gets us partial credit because I'm showing I understand how to set it up, but I just messed up on some simple algebra later in the line. All right, so now we'll move forward. So now we'll go ahead and we'll square this. So squaring a negative makes it positive, and you're squaring a square root, so they'll cancel. So it leaves us with x minus 3, and then you still have the plus 3. So we end up with x. Okay. So that checks off that first part of the definition. Now I got to see what about the second part of the definition, which is if I switch these around, do I still get x? Okay. So now I'm going to say g, and I'm going to replace f of x with this x squared plus 3. So now I get, okay, now we're going to take this, and wherever I saw x, I'm going to replace it with x squared plus 3. So it's negative x squared plus 3 minus 3. So again, setting it up. So this was my substitution, so that replaced the singleton x, because now I'm plugging in all this instead of x. So that's showing up there. Now we clean this up. So now I see, okay, 3 and negative 3, so that's going to be leaving me with a negative x squared. And then the squared and the squared root will cancel, leaving me with a negative x. Okay, is that what we ended up with here? Well, you might look at this and go, wait a minute, we ended up with a negative. It's not x, so we got a problem here. This is wrong. Well, what happened here is, remember that this negative that we threw here in the beginning was just to remind us that what? Oh, what we started with originally, because remember, we plugged in this where x had to be a negative number. Okay, so this is reminding us what? Oh, x isn't just any number, it's a negative number. So yeah, I ended up with what I started with. So remember, x is a negative number. So even though it said this, you can think of this as saying, oh, x was negative. So what happens? Minus a negative, that makes it a positive. So I put this one here as a little trick. It's a little bit tricky here because while in the beginning you might have said, oh yeah, they're not the same. So I would have said, oh no, these are not inverses of one another. I have to remember about that domain, that restriction in the domain from the beginning, because then, oh yeah, it makes sense. X has to be negative, minus the negative makes it a positive. So yeah, they actually match, and I get my answer. So that's where that comes in. Okay, so we did end up proving, yes, they're both equal to x, so therefore, yes, these two are inverse functions. Now, I do this. Let's say I got to that last step and I'm like, I'm not sure. Are they inverses? How can I tell that they're inverses? All right, let's graph it. Remember, what should we see graphically? That the x and y values, they swap. Okay, so I'm going to go ahead and I'm going to plot this in the graphing calculator. So I'm going to go ahead and open up my Desmos. So you can use your own handheld graphing calculator. I'm going to use Desmos here just to quickly demonstrate that. So just share my Desmos screen here with you. So one second while I get this to appear. There we go. All right, so now let's go ahead and we'll plot that in here. So we said it was x squared plus 3. Now I can't restrict it here on Desmos. So we said x had to be less than 0. So remember that. So we're only going to look is at this half of the graph, the left side of the graph. The right side I would not be looking at because x had to be less than 3. Then the other function was negative square root of x minus 3. So you see how I'm getting that bottom part there because I put the negative. If I didn't put the negative, then it's up here. Okay, so the negative is important. Oops, negative there. All right, so now how can I check my answer? Does this make sense? So remember, we're on this side. So I can go ahead and I'm going to use the trace feature here to grab some points. So I see -1, 4. That's a point on the original function on f. So -1, 4. So remember, if we're graphing the inverse, the point has to swap. So the x and y's change position. So if it's at -1, 4, let me put it back here. Come on. Okay, there we go. -1, 4. Then on the inverse function, it should be at 4, -1. So let's check. So at 4, are we at -1? Yup, looks like it. So it looks like we're right on the money. What happens at 0? Well, we'll grab an easy one here. So at 0, it's at 3. So on my inverse at 3, the answer is 0. Yep. So it looks like, yeah, what I showed algebraically is lining up with what I said graphically, or what I'm seeing graphically here. And that's what I want you to start to realize, is that these things are not disconnected from one another. They're both describing the same thing. So what you see with one, you should be getting agreement in the other. If they don't agree with one another, that is a big red flag for you to say, oops, I messed up on graphing. Or, oops, I messed up on my algebra. Let me go back and double check it. So this is why we want to use the technology to help us verify, to catch us when we make those algebra mistakes, as opposed to just kind of like, I don't know, I think it works, I'm not sure, I guess I'll just leave it as is. So we want to make sure by doing it both ways. So this is why in the instructions you'll see sometimes it says to verify using your graphic utility. So it doesn't say go ahead and graph it or draw the picture. Just look at a picture to just verify that what you did algebraically makes sense. Okay, so that does it for our video here. It went a little bit long, but we just wanted to make sure that everything was clear. So again, if you found this to be useful to you, please make sure you hit the like and subscribe button at the bottom, so you get the updates. I can see that this is working for everybody, and I can make changes as necessary, and I will see you guys in the next sets of videos.